Hello there, Mr. Sutton here, bringing you the IM371 Extra Practice Part 2 solutions to Pythagorean Theorem. To find the missing side of this right triangle, since we've already got two sides, we can use the Pythagorean Theorem. So that's a squared plus b squared equals c squared. So the c value here, that's going to be the side across from the right angle, so that's 14. And then a and b are those other two sides. So we can write 11 squared plus x squared equals 14 squared. And then to get x squared by itself, I have to subtract 11 squared from 14 squared. So that's going to be 196 minus 121, which is 75. And you could use a calculator, but just happen to know those. So x squared is going to be 75. To get x, we just have to square root both sides. Now, 25 is not or 75 rather is not a perfect square, but we can simplify radical 75 a bit. 75, we can split that up into 25 times 3. 25 is the biggest perfect square that goes into 75. So radical 25 times radical 3 then, if I square root that. So that's going to be 5 radical 3. For this problem, we're trying to find this missing side of the triangle. Since it's a right triangle and we already have two sides, we can use Pythagorean Theorem. A squared plus b squared equals c squared. C is going to be the side across from the right angle. That's the x side here. That means a and b are going to be these other two sides. So I can write, let's see here, 5 squared plus 15 squared equals x squared. This is 25 plus 225 on the left side. So that adds up to 250. And then if I square root both sides to get x by itself, well, I need to simplify radical 250. I can split that up into 25 times 10. So radical 25, that's really just 5. So then this is 5 radical 10. For this problem, I want to find this missing side. Since this is a right triangle, and I've already got two sides, let's use Pythagorean Theorem. A squared plus b squared equals c squared. So the c value is going to be across from the right angle. So here's our right angle, here's the side across from it, the hypotenuse. That 9 is our c value, and then 7 and x are the a and the b, or vice versa. So I can write 7 squared plus x squared equals 9 squared. Now I have to get x squared by itself, so I have to subtract 7 squared over to the other side. So I'm basically doing 81 minus 49, which comes out to 32. And if I square root both sides to get x, well, the square root of 32, I can actually simplify that radical. So that's 16 times 2, and then that's going to be 4 radical 2. On this problem, I'm trying to find the area of this triangle. So for this one, for all triangles really, you need to know the base and the height to find the area. We actually already know the height. It's this altitude of 9. The base, however, we've got a piece of the base, this 4, but we need this other piece as well. So to get that other piece, since it's part of a right triangle that we already know two sides for, I can use the Pythagorean Theorem. A squared plus b squared equals c squared. And I'm just going to label this side down here as a, just so I can easily refer to it. So using Pythagorean Theorem, my c value out of this is going to be this hypotenuse of 12 that's across from this right angle. So I can write a squared plus 9 squared equals 12 squared. And then this is, let's see here, 144 minus 81 if I'm trying to get the a squared by itself. So that's going to be 63. And then if I square root that to get the value of a, I'm going to round that off to the nearest tenth. I could simplify the radical, but the problem says nearest tenth, so we're going to use the calculator at this point. So I've got square root of 63, and I'll round that off to 7.9. We round our intermediate values to the nearest tenth. So now I've got 7.9 for that side. Now I actually have enough information to go ahead and find the area. So we said base times height. So that's going to be 1/2 times. Now the base is going to be 7.9 plus 4. So I'll just put all that in a parentheses for the base value. And then for the height, they gave us that. That was 9. And let me just multiply all of this out on the calculator. So here we go. I've got 0.5 times that stuff in the parentheses times 9, giving me 53.6 if I round it off to the nearest tenth. So there we are. For this problem, we're trying to find the area of this triangle. For area, we need base and the height. We've actually already got the base. It's 32. The height, however, we still need to find. So let's go ahead and use Pythagorean Theorem now to go ahead and find that. Now, we've got two right triangles that we can use. Each of those right triangles, though, we don't have this bottom side, but since this is an isosceles triangle, we know that this 32 is actually split into two equal pieces. So this side over here is going to be 16. So let me write out Pythagorean Theorem. A squared plus b squared equals c squared. And now we're going to use 16 for this side. So I can write 16 squared plus h squared equals my hypotenuse squared, my 20 squared. And to isolate h squared, well, let's see here. We have to subtract 16 squared from both sides. We've got 400 on the right side. We're subtracting 256. And you could use a calculator here, but I'm just doing it in my head. So that's 144. And I happen to know that the square root of 144 gives us an h value of 12. So now we have enough information to go ahead and use the area formula. So we've got 1/2 base times height for the area of a triangle. The base, again, they gave us that. That was 32. So 1/2 times 32. And then our height we just found was 12. All right, well, let's see here. This is like having 1/2 of 12 being 6. So we have 32 times 6. 6 times 30 is 180. 6 times 2 is 12. 180 plus 12 is 192. And we've got some units here. So that's going to be 192. For area, we have square units, so square feet. For this problem, to figure out if this is a right triangle, we're going to see if this satisfies the Pythagorean theorem. A squared plus b squared equals c squared. So just going to plug the sides in and see if it comes out the same on both sides. So for the c value, we have to use the largest out of these three. That would be 200. The hypotenuse is always the longest side of the triangle, and that means a and b will be these other two sides. So I'm going to write 120 squared plus 160 squared equals our hypotenuse squared, so 200 squared. And let me use the calculator to see what that comes out to. So 120 squared plus 160 squared, that is 40,000. And I happen to know that 200 squared is also 40,000. Since this comes out the same on both sides, that proves that yes, this is a right triangle. Now, you also might have noticed that if you divide all these sides by, let's see here, 40, that you would have a 3-4-5 ratio of the sides. So that's also proof that this is a right triangle. To determine whether or not this is a right triangle, we're going to see if these side lengths satisfy our Pythagorean theorem. A squared plus b squared equals c squared. So a and b are going to be the smaller two sides, and then c has to be the longest side because it's the hypotenuse. So I can write 37 squared plus 120 squared equals 125 squared, question mark, because we don't know if this is actually true. We're testing it. Let's plug these numbers in and see what each side of this equation comes out to. So on the calculator, the left side of that equation is coming out to about 15,769. Okay, we'll take their word for it. And I don't think 125 squared is going to come out to the same thing because you're squaring something that ends with a 5, so you should end up with a 5 for the last digit. But hey, let's plug it in anyway just to see what it does come out to. That's 15,625, which isn't too far off, but it's not the same. Because these are not the exact same number, this proves that we do not have a right triangle. For this problem, I want to know if this is a right triangle or not. So to figure that out, let me plug these sides into the Pythagorean theorem. A squared plus b squared equals c squared, and we'll see if things come out the same on both sides. So for the a and b values, those are going to be the smaller two values because your c value, that has to always be the longest side of the triangle, which must be the 100 in this case. So I can write 63 squared plus 80 squared equals 100 squared. We're not really sure, so I'll put a question mark there. So let me use the calculator to see what these each come out to. So here's the left side of the equation, 63 squared plus 80 squared, and that comes out to 10,369. Okay, now 100 squared, You actually might not need a calculator for this. This is 100 times 100, so 1 with 4 zeros after it, also known as 10,000. This is not the same as 10,369, so that proves that this is not a right triangle.